So this is the attenuator and mixer circuit, the final pieces of the DIY drum machine. So stay tuned for the design. So the last two parts of any drum machine circuit that I had to incorporate are an attenuator, or basically an amplifier, so I could change the various relative volumes of each individual voice as it comes through, and then a mixer, which I'll talk about afterward, to mix them all together. So how does that work? An attenuator is basically a set of 100K or any resistor value potentiometer, and basically each of the individual voices, the hi-hat, cymbal, tom, kick, snare, and low hi-hat, basically go through a 100K potentiometer that are configured as voltage dividers. So what does that mean? So for those of you out there who know how a potentiometer works, you could skip to the next part here. But in my case, when I first started doing electronic stuff, the potentiometer for some reason confused me a little bit, because when to wire it to ground, when to wire all 3 pins, when to not wire all 3 pins. So basically, this is the essence of a potentiometer. A resistive element is what is used in the wiper. And so you could see here, I'm going to demonstrate with some pencil lead drawing on a piece of paper. And you can see the resistance, since this is a pencil lead is conductive. Here, I'm going to measure the resistance now. So as you can see right there, and I'll put the other probe here, and you can see the resistance is measured at 1 mega ohm. And as I get closer to the other probe, it's half that. Now it's 500 kilo ohms. If I get really close to it, it's 300, closer. It is 146K, and let me go real close to it. 23 kilo ohms. So between these two probes. So as it's really close. And so this little level functions as a wiper element and a potentiometer. So you can see the resistance change based on the amount of resistive material in between the two contacts on the potentiometer. So now, for the second part of the experiment, I've wired this pencil lead drawn line as a voltage divider. We have one pencil lead line going to ground. One part of the pencil lead line, this lead, is going to positive VCC. And when I I have this set to measure voltage. And so I have 6 volts of power coming from these 1.5 volt batteries times 4. And so all I have to do is basically put the ground probe on the ground circuit, and then measure the various portions of the resistance along the way. So let's see here. I'm going to put this here. Try not to block the view, touching the ground. Okay, and now let me put this higher so everybody can see. And now, as I get close to the VCC, it's 4.25 volts. And if I go down, it goes down and down and down and down. As I get closer to ground, there's more resistance between this probe and the positive than this probe and the negative lead. And as I get closer to 0, the amount of voltage decreases accordingly. See, it's now 700 millivolts. And as I go over here, it's 3.4, and as I get closer to the positive, it goes all the way to 5. I have a piece of tape here, so I can't really get to that. But it's going to go all the way to 6 if the closer I get to that. So that is how a voltage potentiometer wired with all 3 pins in use functions as a voltage divider. For the distance, as the distance between the output lead, which is this red probe, gets between the one of the 2 power rails, the resistance on the opposite power rail decreases for every bit of rise in resistance. So that is how this is essentially a man-made potentiometer, artificial potentiometer, even though they're all artificial, but there's a jacked up one that I just made. Now, to illustrate use of the potentiometer as a resistor, a variable resistor, I have here an oscillator, basically a square wave oscillator, a CD40 106 IC. It's a hex Schmidt trigger inverter, and basically I have 2 leads here as the resistors. And if I turn it on, I have a sound going to a speaker. And it functions at this frequency based on the resistance between the 2. And as the resistance increases, the rate becomes lower, the oscillating rate, the frequency, and as it goes higher, and that's how to use it as a voltage controlled oscillator here. Using a potentiometer as a voltage divider, you basically wire one side to ground and one side to your input signal of the voice, right? So these voices enter at pin 3 and pin 1 goes to ground, as if you're looking at the potentiometer. And that way, when you turn the potentiometer clockwise, there's less resistance to the actual signal and there's greater resistance to the ground. And so effectively that increases the volume of your signal coming through. The opposite of that is also true. So if you rotate this counterclockwise when it's wired in this configuration, you get increased resistance to the signal and decreased resistance to ground, and you decrease the volume of the signal all the way to 0 if you have to. So the way that works is the potentiometer is basically a voltage divider. And there's a big resistive element in this outer ring here. And the outer ring, part of that resistive element is connected on either side to whatever you want to connect it to. In this case, it's the input signal and ground. And there's a wiper in the middle that makes contact with this resistive element. And then that contact is connected to the output of the signal. So as you rotate this wiper clockwise, the amount of resistance in this area decreases. So essentially, the amount of this resistance decreases and the amount of this resistance increases. And as a result, you get a stronger signal going to output and less of it can go to ground. And when you turn this the opposite way, you have very little resistance to ground. So most of that input signal will go to ground, and a smaller amount of it will go to the output, effectively decreasing the volume. And that's how the potentiometer works as a voltage divider. Now, using this concept of the potentiometer as a voltage divider, I have here the previous circuit, the mixer circuit that I made, and the output of which is going through this potentiometer here. One leg of it, that green wire, is going to ground. Let me move this. One leg of it, the pin 1 is going to ground. Pin 3 is the output signal through this red wire. And the other one is this blue wire, which is the output, the middle pin. And I have it set coming from this oscillator at 12 volts. And basically, as I turn this up, it goes from ground, and now you could hear the volume. And that is how the potentiometer works as a voltage divider.